Hello and welcome back to the channel. So we are going on with the chapter of simple machines, and this is the third part of this simple machine. The previous two parts of the simple machines are provided in the description or it will be provided in the I button. So please watch that videos before going on with this video. So in the third part of this simple machines, we are going on with the types of lever in this video. So what are the types of lever? First one is class 1 lever. So what is class 1 lever? In this type of lever, let us suppose this is a rod and on one side it is containing load and on another side it is containing the effort, and in between the load and effort it is the fulcrum, like for example which is the seesaw that we see in the parks, that on one side it is the load and on the other side it is the effort. Suppose that on one side this load is a child and on the other side this effort, this is also a child, and in between a support is there, as you can see in the seesaw, it is the fulcrum. So this is the class 1 lever. Now as I have already mentioned in the previous video that from the load to the fulcrum it is the load arm, and from the fulcrum up to the effort it is the effort arm. So now what we have got, the mechanical advantage of a lever, it is the effort arm by load arm. So depending on that formula, the mechanical advantage of class 1 lever can be less than 1, is equal to 1 or greater than 1. These can be the three possible conditions of mechanical advantage of class 1 lever. Now how this condition comes? Suppose that this fulcrum, which is on the middle, slightly moves towards the load, and it is the position of the load, fulcrum and effort as visible in the screen. So now what we can say, that load arm is less than the effort arm. That means effort arm is greater than load arm. It means what? It is the ratio effort arm by load arm is greater than 1. So this is the one condition. Now if the fulcrum is exactly in the middle of load and effort, that means load arm is equal to effort arm. It means what? The ratio effort arm by load arm is equal to 1. So this is the second condition. Now the third condition, if this fulcrum slightly gets moved towards the effort arm as the positions are visible in the screen, it means that effort arm is less than load arm. That means the ratio effort arm by load arm is less than 1. So these are the three conditions of mechanical advantage for class 1 lever. Now what is the second type of lever? It is class 2 lever, or we can say lever of second order. So in this lever, the position of the load, fulcrum and effort are like this. This is the fulcrum. That means fulcrum is on one side of the rod and on the other side of the rod it is the effort, and load is in the middle. This is the fulcrum, this is the effort, and in between load. So what are the examples of class 2 lever? As you can see in the screen, these are the examples of the class 2 lever. So now comes what is the mechanical advantage of this class 2 lever. Again, mechanical advantage of a lever is effort arm by load arm. Now as I have previously told, from the load to the fulcrum it is the load arm, and from the fulcrum to the effort it is the effort arm. As it is clearly visible from the screen that effort arm is greater than the load arm, what we can write from the diagram here. From the diagram here we can write effort arm is greater than the load arm. So what is the ratio coming? Effort arm by load arm is always greater than 1. Therefore, what is the mechanical advantage? mechanical advantage is effort arm by load arm is greater than 1. Now comes the third number, that is class 3 lever. So what is the position of this class 3 lever having the fulcrum, load and effort? It is just like this. Consider this as a rod, and on one side it is having the fulcrum, on the other side it is having the load, and in between there exists an effort. So what are the examples of class 3 lever? These are visible as in the screen. So now let us calculate what is the mechanical advantage of class 3 lever. Now mechanical advantage of a lever is effort arm by load arm. So as from the diagram we can write effort arm is less than load arm. So what is the ratio we can write? Effort arm by load arm is less than 1. Therefore what is the mechanical advantage coming? Mechanical advantage is equal to effort arm by load arm. From this ratio we can write less than 1.